On this first equation, I have solved 3 all over x plus 1 minus 9 all over 4x plus 5 equals 0. So I have two rational expressions that are subtracted equals 0. By adding one of those rational expressions to the other side, I have 3 all over x plus 1 equals 9 all over 4x plus 5. So I've created a proportion. So I have something that's like A over B equals C over D. And so what I can do, some people call it cross multiplying. What we're really doing here is multiplying by the least common denominator on both sides, but that essentially amounts to multiplying the diagonals here. So 3 times the quantity 4x plus 5 is equal to the other two quantities that are diagonal multiplied, 9 times the quantity x plus 1. And from here, we have basically a linear equation. I can distribute the 3. I get 12x plus 15 is equal to, if I distribute the 9, 9x plus 9. And then I'll collect like terms on each side. So I will subtract the 9x from both sides, and then I'll subtract the 15 from both sides of the equation. And on the left side, I'm left with 12x minus 9x is 3x. On the right side, I have positive 9 and then minus 15, so that's negative 6. So 3x is equal to negative 6. We'll divide both sides by 3. And I have x is equal to negative 2. So we want to do a quick check when we have a rational equation that our solution won't create a 0 in the denominator of any of the rational expressions involved. And here, negative 2 will not create a problem. On the next example, I am going to solve 3 over x plus 8 all over the quantity x minus 5 minus 1 equals 0. So this time I have 3 terms, and so I can't just simply maybe add one or subtract one to the other side to get that proportion. So here what I'm going to do is I'm going to create these quantities to have common denominators. So there are technically 3 denominators involved, x, x minus 5, and of course 1. So the least common denominator is x times x minus 5. So I'm going to have to rewrite each of these quantities with the denominator of x times x minus 5. All right, and that's going to equal 0. So here, 3 over x, well, there was already an x on the bottom. So if I put an x minus 5 on the bottom, I have to balance it by putting an x minus 5 in the numerator. And there was already a 3 up there, so that has to stay. And then the middle term, 8 over x minus 5, my new denominator has to be x times x minus 5. There was already an x minus 5 on the bottom. So if I put an x on the bottom, I have to put an x on the top, multiplied to the 8 up there. And then the last term, which was just 1, well, if I put x and x minus 5 on the bottom, I need an x and an x minus 5 on the top. So same quantity over the same quantity, these will reduce down to just 1. But what this allows me to do now is combine all of these into one rational expression on the left side of the equation. So I'm going to have one big fraction bar here with that common denominator, x times x minus 5. And then I'm going to go across all of the numerators and combine those together. So I'm going to have 3x minus 15, so the 3 will distribute, plus 8x. And then here we have to be careful, there's a minus here, so this negative x times the quantity x minus 5 becomes negative x squared plus 5x. This negative x distributes to both, so make sure those two negatives become a positive. And all of this is equal to 0. So now in the numerator, let's combine like terms. There's no like terms to negative x squared, so I'll put that first. 3x, 8x, and 5x, all of those are going to combine together to give me 16x, and then minus 15, all over x times x minus 5 equals 0. Now in the numerator I have a quadratic, and I'm going to factor it, but actually I'm going to first take out the negative. So I'm going to factor the negative out of there. I'm left with x squared minus 16x plus 15 all over x times x minus 5 equals 0. Just because I'd rather factor with the leading coefficient of a positive 1. And so this is going to factor to, let's see, x minus 15 times x minus 1 all over x times x minus 5 equals 0. Whew, this was lengthy. So now what? I mean, I had these three terms equal to 0. We found common denominators. Now we have one rational expression equal to 0. Well, the only way that a fraction equals 0 is if the numerator equals 0. So what I'm going to do is I'm going to set x minus 15 equal to 0 and x minus 1 equals 0. If either of those factors is 0, the numerator will be 0. So if I add the 15 to the other side, I get x equals 15. If I add 1 to the other side, I get x equals 1. So my two solutions are 1 and 15. And a quick check that those values do not make the denominator equal 0, and they do not. So they really are values that will make the original equation equal 0. And finally, we have solve x squared minus 25 all over x squared minus 3x minus 10 equals 0. So we just have one rational expression is equal to 0. And as I mentioned a moment ago, if I have a fraction, the only way a fraction equals 0 is if the numerator equals 0. So here, since I already have one fraction, we can move forward with setting the numerator equal to 0. So if I solve, when does x squared minus 25 equal 0? I can solve by factoring x minus 5 times x plus 5. If I set each factor equal to 0, I get 5 and negative 5. So I get what looks like two solutions, but this is a trap. So here, both of these are actually not values that will make this equation equal 0. One of these is not going to work because one of these makes the denominator equal 0. And we can only have a solution or a fraction equal 0 if only the top equals 0. So here's what we really should have done in the first place, is we should have factored both the top and the bottom to start this problem. So we know the top factors to x minus 5, x plus 5. The bottom, if we need two numbers that multiply to give us negative 10 and add to give us negative 3, that's negative 5 and positive 2. So if we factor the top and bottom right away, we would notice that the x minus 5 factors are going to simplify to just 1. And so we really only have one quantity on the top, one factor that we're going to set equal to 0. So only x equals negative 5 is a solution to the equation. So if we plugged in positive 5, that creates 0 over 0, and we can't have division by 0. So only negative 5 is a solution to this equation.